So we had a main intention of making the machine to do something like a fill in the blank task using the deep learning technique. So as a first phase, we wrote a function which you can see here. This is to read the data, right? As you already know, the data is present. That is my data, right? Where there are 1040 sentences, and after each of the sentence, there are five possible answers, out of which only one is correct, right? And which is correct? I think we have it in the form of the my answers dot text, right? So which contains all the right answers. Okay, out of which our first intention was to read the given data set, right, and convert that into set of sentences in the form of a variable s. Then wherever the blank space is given, identifying the underline starting and ending of that, and all the possible answers and the right answer, that is in A, right? So we wrote a code to convert, right, uh, from the given data to read all this, right? So then the next this thing, we our objective is now to prepare the data in the required format. Again, though we read the textual data, it's not enough if you have the text data as big, because machines basically cannot process the text. You need the numbers. Somehow you need to convert them into the numbers. All right. So that was our objective. So this is something like a prepare data sequence uh, code which reads the data, puts it into the variables SUVA, then converts them into the required format. So in the required format, I'll just run that and show what is our required format. So as you can see here, there is we read by using our read my data command, right? That's this function. It gets executed. SUVA will be created. We can see that there is S, U, B, and A, right? As expected, SUVA will be holding S, the all the sentences, right? All the 1040 sentences are there in this. Okay, that's S. Then U, starting and ending locations of the underline, right? We all the possible words for each sentence, there are five words, right? So we try to extract that over here, all the 1040 into five columns, right? And A holds the answer, right? So answers, what we did in the code is that we don't want A, B, C, D, and or E. We want 1, 2, 3, 4, 5. So converted that into the numbers, right? So that's what is presented here. And in this code, we can see what we did. So first we read the number of sentences. We created two variables C and Z, right? One is a one initialized with all zeros, second one initialized with strings. We have not assigned anything so far. Okay, but what we do for all the sentences, right? In the sense starting from 1 to 1040. So everything before the dash we extracted, everything after the dash also we extracted, right? That's Q1 and Q2. Then we try to create five different sentences. Out of the five sentences, only one will be correct, right? So what we did, we tried to wherever there was a blank, we try to replace it with all the five possible answers, right? So the five possible answers, we put it into Z of K, and one thing we are sure that only one of them is right, where J becomes equal to A of I, right? So if J becomes equal to A of I, that is nothing but the right answer, right? So we hold C of K equal to 1, otherwise C of K equal to 0. C of K 0 means it's a wrong answer. C of K equal to 1 is right answer. So C will hold what you call as uh, the index, right? Which is correct. It's a flag. Okay, so let me open the Z for you. There are, you see, each sentence is repeated five times, because right there are five different answers possible. But you see there is crying, this is replaced. Second sentence has instantaneously. Third sentence replaced with residing. Fourth sentence, right, match. Then fifth one is walking. So out of these five, only one is correct, which is that one. That's the third one. Right. But how do you train the machine that third one is correct? You use C. So just open C. You can see the third one is 1 out of the first five, which is the same copies of the first sentence, right? But every blank is filled with all the five possible answers in each of them. Right. Only third one is correct, so you understand. So this is still here. We did. Is it okay? Right. So we finished that now. So our next intention is nothing but I want to create a numeric dictionary. Right. So far, what I did, right, I simply tried to convert the data set ready for training. But this is not enough. You need to get into what is called as the numerical array is required because machines are going to handle the numerical data easily than the text data. Correct? So even the text will be processed in normally the ASCII format, right? So because of that reason, now our intention is right to convert the data set we have. I want to convert that data set into let us say a dictionary, right? Containing right which letter is what number, how do you represent, etc. We try to do that now. That's our first objective. Okay, we are going to do that in the same code. Let me divide this into another section now, and let's try to do it. Right. We'll start with the first one of Z. Okay, so let me call that as a is equal to Z of 1. I will start from the first section. So if I try to run this, I'll get a new variable R in my workspace. Let's see what it contains. Okay, so I'll run this section. So see the R is created. It means Z of 1. So first sentence is being read. Correct? Out of the Z, right? Z has 5 copies of each of the sentence. Correct? And out of those 5, only the first one is being read. That is right. So start from, let's try to append my Z of K to this R. Okay, what I'm trying to do here is I'm trying to append all the sentences into one string. I want to convert I want to put all the strings present in this Z into a single variable called R. So how do I do that? I'll use a for loop because I know how many iterations I need. The number of iterations should be equal to for, let us say K is equal to, I'll start from 2, that's the second sentence, start from the sentence number 2 and go all the way till the end of Z, right? So Z, what is the Z size? How do you find out the Z size? I know that Z size is 5200. But what is the command to see that? It is length function, correct? 2 till the length of Z, right? Start from 2 till the length of Z, that is 2 to 5200. Repeats on. What do you want to repeat? So R should be equal to, right? Append can be done using the plus sentence. Whenever you are in the string mode, right? Definitely you can, if you remember from the basics of Matlab, right? R is equal to R plus, I want to use a space, right? Between the two sentences. So plus Z of K. So what do you expect? At the end of this, right? I should have a R that containing all the sentences inside. Let's check whether we are going to get that. I'll end this. Okay, so let me run this section. It's still processing. It's reading all the 5200 sentences. Now you see R, right? Let's open this. You see, it's not just one sentence. Okay, you see, it actually keeps on going. All the 5200 sentences are there inside this. Okay, so anyway, it's not possible to show all of them on the screen. So that's fine. Anyway, we understood what we did. Correct. So this is my first step. I tried to convert. Now you see there is a command. Okay, I have to write a code now. So I'll come to that. So I need to find out how many distinct words are there because I'm trying to build a dictionary, right? So let me try to do this. So D is equal to I'll call a function, but anyway, this function is not there. I need to write it. Okay. Find find distinct words. I'm supposed to find this. Okay, in this R. right? So I have to do this. Let's do this later. Let's try to write a code first, right? So I understand that I'm getting that into D, right? So D will contain the distinct words present in the variable R, which contains all the sentences. Okay, now let us try to create another variable which is a cell type representation of the length of Z, right? So that is, I'm going to call Z is equal to create a cell, right? So creates a cell structure, right, of the size length of Z, right? Length of Z means you know now, right? What's the length of Z? That is 5200. And I need only one column, right? One column, right? And the length of Z, so many rows in the cell. It's a cell structure, right? Let's, I also do need to do one more thing now. So that is, mm, for every word that is present in this ZK, I need to convert that into, right, the equivalent cell, right? Because you see, uh, I do that by making a conversion, right? I try to perform what you call as the mm, 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 conversion of the text into numbers, right? For that, anyway, there is no built-in function to do that, right? So we need to write another function for that. Let me try how to do it, right? So anyway, I'll call the function here, but we'll write the function in a separate file later, right? Like we do for functions always. Is it okay? Right. So for, it's a for loop because for every sentence inside the Z, I need to do this. So again, for k is equal to 1, starting from the first sentence to the last sentence. How do you identify which is the last sentence? That is length of Z, correct? So for all the sentences, this is just a length. K varies like this. I have to address the Z now. So numbers Z, I called it as a number Z because it contains only numbers now. Okay, num Z. What is num Z? Num Z is a cell. So access the, in order to read, write, or access or index the cell, you should use the flower brackets. Correct? Right. Flower bracket K. Num Z of K is equal to, right? How do I get the entry inside K? Inside Z, num ZK. Num ZK is a cell corresponding to each of the what you call sentence. Each sentence in this, right? I need to replace this whole thing by a number. In the sense, I will be a number. So every text I want to replace it with a number. How do you do that? I will call a function. Okay. So the function that I'm going to call is the uh, text to numbers. I want to write a function this, which actually takes in two parameters. Okay, so the two parameters are, the first parameter is the Z of K itself. Okay, Z of K is the complete sentence, right? You see, when I'm reading Z of 1, it will be put into a cell called num Z of 1. Okay, right? When you read the second sentence, it will be put into a second cell, num Z of 2, and so on. All the 5200. And now you see, I need this D now, because this, according to the distinct words, I need to do this. So I'll pass the D as well. So how do we deal with this? How do you convert, etc.? We'll see later. So as of now, I'm just using a function which is not written yet, but we'll do that. So every sentence is converted into a series of numbers that is present in num Z of K now. Is it okay? So what we do directly, let's go for, okay, that's N. All right, let's check whether this works later, because as of now, we have not written the two functions so far. So it's not going to run. If you simply try to run this part, it's going to throw up an error saying that there is no find distinct words. And you see, it says that. find distinct words is not, you don't have it. Okay, see, similarly, right, this is also not there. The text to numbers is also not there. So anyway, we cannot run this part until and unless we have both the functions ready with us. Okay, all right. Right, let's directly go back and let's try to do what is called as, we'll try to write the functions one by one. Okay, so I can see that I need find distinct words, right? I need to write that first, right? So let's write, it's edit, find the distinct words. Right. So the function. Okay, let me try to decide what I want to return. Uh, maybe. Okay, let's decide what we will return later. This is equal to, I'll write at the end. I'll fill this brackets at the end. So the function name should be find the distinct words in the given sentence. Maybe I'll call the sentence as W. Okay, right. So now you see, this is actually again a pre-processing. You may have various types of punctuation marks present inside this W, right? Say they are not considered as any sort of words, correct? Because what you are passing to this, go back and check. So see here, right? Find distinct words present in this R, right? What is the R? R is nothing but all the sentences in your the database. So that may, what we are, our intention is to find out only the uh, distinct words present in that, right? Like a building a dictionary. But that is not possible whenever you have colon, semicolon, maybe, right? The full stop, etc. Right? Those are the various, right? The punctuation marks we have. Let's try to remove that now first. Okay, so how to remove that? There is a, right, a function. Let me check that. Erase. So just see, remove the specific content from the text, right? You have to tell which string and what is the pattern you want. So if you say remove, right, like this, if you want to remove this pattern, call this as this space quick will be eliminated, and so on, right? Whatever you want, you can remove from this. That's the command called erase. Okay, so now what are the things you want to erase? Every punctuation mark that is present inside the text you want to erase. That's the fundamental idea. So W is equal to, right, erase, right? From which text? W itself I want to erase. What you want to erase? You want to erase the character like this. Okay, so that will be erased if it is present, right? Another W is equal to, once again, erase, right? From the W itself I want to erase. Now, so anyway, semicolon is removed. I just want to remove if there is any comma. So all the commas will be erased. Once again, W is equal to, these are the various punctuation marks I found inside that. Okay, let's see whether this works. If it is, there are some more punctuation marks remaining, we'll try to remove that later. Okay, so this is once again equal to erase from W. I also observed the full stops, right? So let me remove that. They are not the part of the text. Sorry, they're a part of text, but they're not the words. So our intention is to find the distinct words present over. Is it okay? Right. Now let's try to, there is one thing, another function I want you to understand. That is a split function, right? So let us say help split. So you can just see the examples to understand this. Let's see. So split str means wherever you have a space, right? According to that, it will get splitted up. right? So you see string equal to this, you use when I say split, this becomes like this. In a sense, every individual, right, words will be splitted up from the text, right? Split the strings in the string array. Right now we are having a string array W. From there I want to extract the words depending upon the space. So by default, the delimiter will be the space itself. Okay, wherever it finds a space between each word, we have space, right? So it will identify that there is a space and it extracts the words accordingly, right? So that's what is the use of this particular command called as a split. Okay, so let us directly use it. So first let me use s is equal to split of say this W, but I want to have it in a column format, so I use a, right, transposing, right? And there is another command. This is also very used. I think we have used this in the fundamentals of that is to find the unique words or unique things in the in any array, right? So that is health unique. So what you are going to do, right? It creates a unique set, right? If I call unique of A, so it returns the same values as in A, but no repetitions, right? So you see that when I assign like this, the C will be a new array containing no repetitions in A. If the word say hello is repeated twice in A, so C will contain hello only once. So every unique word that is present in A will be copied into this. So that's what we are expecting. Okay, right. So what I'm going to do now, I'm going to use the unique command to put it into D. So D is equal to the unique content from S, because S contains all the words, right? So from that, extract this. Right, now you see, I need to find the numbers for the words, right? So let me assume that I will pass even that a number, n variable I'll try to pass. So one of the output that I want to give here is a D, because that is a unique word, right? I also want to pass something else. I'll show you what it is, right? I want to calculate the number of words there. So for that, uh, okay, let me create. So that is n is equal to, say, initialize with zeros of 1, length of s. So s is what? S is the splitted version. How many total words are there? That will be the size. Okay, in your text, total all the 5200 words clubbed together, how many words you have? That's s. Okay, length of s. So many, this is the number of columns. So many zeros are created. One row, so many columns. Is it okay? That's what is n. Anyway, I'm going to return even n now, but I'll fill this n with the appropriate answer. So that is what I try to do. How many times, yes, in this s, how many d's are present? In the sense, unique word, say hello is repeated how many times in the total s? That's my question. That is all. That is what I'm going to return n here, right? So that's the n. Okay, see in this function, we can see that I'm returning two values, d and n. D are the different distinct words, and n is the number of times it is repeated, right? Makes sense, right? We need that. So okay, let's try to write like this. I will start with, say, okay, I have a count with me, so better to start with a for. So for, do you have used any variable here? No, nothing to find. So I can start with a two. A is equal to 1, 2, uh, uh, length of s, because I know that that's the total zeros I have in n. For k equal to 1 to length of s, I want to check in that during that whole duration, how many times the D is present. Unique words are present how many times, right? So I actually need another loop. For that is J, they equal to 1, 2, uh, length of D. Okay, so two for loops. So K will hold the one by one, the length of S, and I'm cross verifying that is it present in J. Sorry, is it present in the D? So that's why length of D. So what I am comparing, so I'll use a if condition. So if, right, I have to match whether they are equal, right? So I can simply write, I don't need a bracket here. So D of J equal to S of K. Are you getting what I'm trying to compare? There are two arrays, right? Element in the first array, is it there present? Is it present in the second array, right? Throughout. So J will be continuously iterated throughout the length. Every time D changes, you check whether that S of K is there in D of J. If it is there, you say number of where and all it is repeated. I want to check, right? So N of K should be equal to the J itself. So J means it is 1, 2, 3, 4 up to the length of D. So many unique words, right? Where and all it is repeated, you will come to. Fine. So once it is found, say, I don't want to continue, break, right? Then end this if condition, end the second for loop, end the first for loop, and end the function. So that's done. Is it okay? Right. So now I'll demonstrate how. Let's check whether this works or not. Okay. So uh, and all right. Okay. Let's try to run this once to verify that whether this is working fine. Okay. Save this and let me copy some text. Right. So I'll put that into. Okay. So this is the W, which is a text now, and I want to call this function. Okay. We call it that. So D and N, right? I just want to check. Hope there are no errors. So D and N needs to be created over there. Yes. You see D and N are created. You see D is nothing but the unique words present in the whole text, right? You can see here there is no one. We have one. Okay, I think it is in the ABCD, that format, right? All the A's are first, then B, right? Then C, D, F, G, L, M, N, O. Yes, okay, it's in that form. Anyway, that doesn't matter. It's no problem. So that's D, as you understood, right? This is our intention, right? I want to extract each unique word present in the string. So whatever is repeating, right, in the string is not copied, right? So that's first thing, right? They say that, so there are 38 unique words. So how do you identify that? This is 1 into 38. Is it okay? Right. And then let's move further. And the next thing is that I want to check what is n, right? So let's see, right? You see where each of the word has been identified. So the no which is present in the first position, right? This is the, what was the second word? That is A, right? You can find that in the 26th position and so on, like that, right? So you can see every number that you found, you have different locations corresponding to that. Okay, all right. So there are totally 47, right, words in this, out of which 38 are unique. That's what is the meaning, right? And each of the unique word repeated at all these locations, right? A may be repeated several times. You can see, right? There is a over here, another A may be somewhere else, right? Again, 26 will definitely come once again, right? So, and so on. Okay, so those are the different locations where you can find these values. Okay, all right. So anyway, so that's what is this whole function is trying to do. Anyway, that we have used over here, right? I'm just using D. D is equal to find the distinct words. That's all. So anyway, I don't have to written N also, but if at all read it, I can do that. I can do it in this way, right? So I can actually make a right in this find distinct words. I'll put a condition here. So that condition is uh, I can use say I can put one. Yeah, I can put one condition if say I'll use all right. Only then if the n is asked, then you give n. Otherwise, don't do this. That's what is my point here. I'll say that if the number of outputs can be calculated automatically by using n is a number of arg n arg out greater than 1. So if the number of arguments is this, then do this. That's what is the point, right? Let's this finishes here. This is the end of the this and this. So that this closes. Yeah, everything is right. Okay, now let me try to run this once again. Now I'm not passing the n. I'm asking only for d. Let's assume. Okay, it should come because it finds that there is only one output. Only d should be clear. Okay, so here d and n, only those two will be erased. Now I do this again. So go for d is equal to this. So d gets created. Only the right, only the unique words are extracted. Okay, I think that is fine for the time being. Right? If we need, we can extract because when I wrote the code, I just used that d itself. Find out only the unique values. I don't want where is. So actually, right, we can neglect this part as well. Okay, for the time. Okay, so anyway, that is done. I'll save this. Also, I need another function, right? So what's the second function we want? That is a text conversion of the text into the numbers, correct? So I want to check that. How do I do that? I want to convert the text into numbers. So let me copy the name I have here. Okay, let's open a new thing, right? So this is a function, right? Say the number I want to return, n should be equal to uh, the same name which we had given, and look at the various what are the parameters you want to be passed so that you can do this, right? So what are the parameters? One is z of k, right? It z of k will be containing the string array, so I can call it by a single variable name, and d. So two things will come as input. So let's check that. One is a set of words. I'll give a name w, and the d, that is a dictionary, is going to come into it, right? So two things will come as input. Okay, so those things will come. Once again, right? Let's take a precaution. When I pass this w, there may be the punctuation marks. Okay, so let's try to do the same job we did earlier. So w is equal to erase from the w, right? First we erase the, I think the colons or semicolons. Semicolons are there, I guess. So let's erase the semicolons. Then w equal to erase. What do you want to erase? From w, let's say the pattern that I want to erase is comma. Many times I found commas over there in the text. Again, w is equal to erase W. Come on. S is equal to, you see, we did the splitting option, right? Of the remaining, the final W, whatever we have, take a transpose. Okay, then N is equal to, we create the same, this thing, what we call, first let's create the zeros now. Of size equal to 1, length of S. So many zeros will be created. Okay, now you see what is the use of N, right? So I start with the for let's start with K equals to 1 to length of S. First, I'll try to find out the indices. So I'll use a word called IDX. Index is equal to, I need to find, so the function is find. So let's go back and check what is a find. Help find. Find X basically returns the linear indices corresponding to the non-zero entries in this, right? Wherever there is non-zero, you will try to, okay? So what I do, instead of this X, I will make a comparison. So find of wherever, so I'm comparing strings. So which command you need to use? If you recall the fundamentals of Matlab, so you are supposed to use strcmp, okay, string compare. What are the two things I want to compare? One is S of K. What is S of K? Just recall the splitted words, correct? The words which we had splitted, I write a D. That's my dictionary, right? So compare, and wherever they are matching, I put that as index. That will be a 1. Otherwise, it's going to be 0. All right. Next, I'm going to check, right? This index is empty or not, right? So I'll check that because there is a possibility that none of the words are matching. Right? So that's why. So if, right, I'm checking is empty. So is empty means it will answer yes or no. Okay. So if it is empty, then only I'm going to do some. If it is empty, sorry, I put my words in a different way. So I'll check not, I'll check is empty. Whenever it says it is non-empty means there is something, correct? Whenever there is something, I'll do that. Okay. Whenever this IDX is not empty, how do I check not empty? Not of is empty, right? So if IDX has a value, is empty of that value is answer false. Take a not of that false, it becomes true, correct? So I want to do this, right? N of K is equal to, put that index value to the NO. This N is what I'm trying to return now. That's the number. All right. So you'll see now how this is going to run. So that's the end of this. Then, okay, let me end the for loop. And I'll also do one thing. So wherever I have N of, if equal to 0, N equal to 0, if at all you find zeros over there, right, make it a null. Don't write any numbers and return over there. Say that it's not, okay. Let's fine. So I hope this works. Let's check. I'll use the same set of words. Clear this first, then I paste this. I will see this was my original sentence which I used earlier. Then you see, in order to calculate, in order to run this function, I need d as well. So how do you calculate a d? If you remember, d is coming from my other function, right? So what is that function? Distinct, finding the this one, correct? Right. I don't want n, so I don't want to calculate that. Okay, so this is what. Okay. Anyway, that comes in the d now, right? Now you call this the one which I wrote just now, right? So n is equal to, right? Now I have to create a new variable n, right? Which you can see that is 1 into 47, right? You see, right? That's getting converted into a number. All right. So we got all the 47 words have been converted into, right, in the form of a dictionary. That's all. Okay. So anyway, I don't need to calculate the n at all here. So I will remove that completely. The n part you don't have. Okay. So this part I don't. Only the d is required. Okay. So this complete thing you don't have. Simply return the d. Okay. Let me don't. I don't want to keep it complicated. Right? So let me run this once again. So what are the variables? D and N I need to clear, right? Then I write W, anyway, it is already there. All the D once again. So D is equal to this, done. Then you do N is equal to the numbers. You converted the text into numbers, both are present. Okay, so this means it is working fine. So I have the first function. This is my second function. Okay, preparing of the data sequence, right? We have prepared that now. So let's try to verify whether I am able to run and get something. Okay, I'll come back to this now. Anyway, we have those functions ready with us, so we can actually run some. Okay, so I'm coming back to the prepare data sequence. You see here, first I read, I converted into ZK. Now I am writing another this thing to create a dictionary where I wrote till the using find distinct words in this and converting the text into the numbers. Okay, so those things I used it here. So let us try to print any of the sentences to check that, right? Uh, whether it's going to work. Okay, this is let me try to make a new section here. But before that, let's run and check this. Okay, because still here, I should be able to. Everything will be cleared, and up to num z of k should come here, right? So that means yes, we are up to something. Still running, it's busy. Okay, you see, you got a variable called num z. Let's open that. So see the size is 5,200 integers. Let's open the cell. You see the numbers have been right created. So that's one thing. That's num z. Also, let me check what are the other variables we are creating in the middle. One is r. Till r we already have seen. We see d now. See the d which we are going to get right now is different. There are how many unique words you have. See the unique words are right. How many are there? Out of the all 1040 sentences, you have 5887 unique words. Okay, there are so many unique words. Okay, I think I can even remove. There is one thing you see here. It's just a blank, I guess. Okay, I'll try to. Even the numbers are there. So all the numbers are also put up into as it. They have been recognized as individual words. Okay. All right. Let's hold on to this. Anyway, it's not giving any error so far. So that's fine for us. Okay. Num z has been created. So whatever is the total overall length we have, according to that, num z has been created. Each one is an array. Okay. Each array will have, right, the repeated words present. Right? So num z of k is the number version of that. This is what I told you. You have to give numbers to the machine rather than giving the text as it is. So the num z is what we are going to use for the further use. But I just want to check what exactly is going to happen for any of the text I give as input. For example, let's try to create a small array for say k is equal to 1 to 10. This is just a testing part. I just want to check that whether this part of the code I have written is working fine or not. All right, so I'll do a f printf. I want to say that this belongs to a specific category, so I'll just engage D and I'm going to write C of K. Then f printf percentage D. I want to write Z of K. So I need to access. This is a cell array, so use this. Okay, so that is also that will get printed. Then f printf. I just want to go to a new line. All right, so we'll check if mod of the k comma 5. See, I'll try to plot only two sentences. That's why k mod 5. So k mod 5, k is 1 to 10. K mod 5 becomes equal to 0 how many times? In 1 to 10, only two times, when 5 and when 10. That's why. Okay, I'm checking this and I'm trying to print some. Okay, so if this is equal to 0, I'll just write f printf, say okay, let's see whether this part of the code works and how this is good. I just want to print two sentences. Let's see. Sorry, there is a mistake. What is that? Which line it is? F printf. Oh, I didn't close it. You see, right? Everything is converted into numbers. This is what I want ultimately. Correct? So whenever something is, this is the two categories. One category is this, another category is this. Okay. So you can see that the numbers have been created. So the first one says 0, 0 means this is false. This is the right answer. See, 1 is there. This is the right answer. This is a wrong answer. This is a wrong answer. So, and corresponding to the right answer, the sentence will start from here, goes all the way till here. Okay. Similarly, you see, right? For wrong answers, these are the two sentences, and these are the other two sentences. So like that, right? We are trying to anyway. So it's conversion and writing that. So I'm just typing that. Maybe I'll get a more clarity if I write the numbers here. Let me just check. Yeah, this is more clear. Okay, so because I didn't give any spacing here, right? So this was actually not so clear. Now I actually made sure that, okay, give the proper spacings. So consider this now. So this is the first word in the first sentence, second word, third word, fourth word, and so on. Somewhere at a point we see a difference. Until there, you see this is a difference. You see 1425, the first blank filled with the first word, first the blank filled with the second word, blank filled with the third word. This is the right answer. You see, this is one. Are you okay? Everything is being converted into number. Ultimately, that's what we did. So that's all. So numbering is done. Now I need to save this because anyway, what you created a database now. Where is the database? The database is present in. Okay, I'm present inside this. So do I have this sentence? Number of sentences I have. Okay, I will create a, you see, I'll create what is, anyway, this is not required as of now. So this is just a testing purpose, right? Only when we need, we can write that. Otherwise, I'll comment it. So what I do, I'll save something, right? Save uh, my my database. It's the file which we are going to create now that will come in the current folder. And I want to save only two things here, right? The first thing is the number of the NUMZ, right? MZ, this is required because this is the cell array, right? I want to save this. And also I want to save, which is the other parameter which you think is useful in this whole code. I need, you see, you need about this one, right? Whether which is correct answer, which is wrong answer. Where is that present? That is in C, right? C of k is 1 for true, right answer. C of k is 0 for that. So you need to also to save C, correct? So I think small letter C, that's done. So now I run this so that I get a new file, new .mat file by this name, my database. Okay, if that is done, so this part of the code is working fine. Now after that, directly we can jump into the actual coding of the deep learning. All right, let me just run this and check whether we can. Okay, still busy, you can see, right? It's processing all the sentences, right? There are 1040 in original, but later on it changed. Now you see here, this is my database. You can see that inside that we have num z as well as the C as we requested. Okay, so looks like the pre-processing is complete, right? Next class we'll directly jump into the writing code for the required deep learning concept. All right, okay, see you then.